Alright, this is section 5-6 on least common multiple. We're going to start with some basic concepts. First is to understand that this is a lot different than greatest common factor, which we've done previously. Greatest common factor was where we were trying to find what goes into both of the terms that you had, and in this you're trying to figure out what both terms go into. So you expand the terms we have in least common multiples. You multiply, you get bigger to find out what they both go into. So let's start with example 1. Here's example 1. Example 1 wants you to find the LCM of 108 and 240. So, one way to do both of these, just so you have the concept, is to write out all the multiples. We could take 108 and just keep expanding it until we eventually came to the number we like. And that would keep going, and then we would do the same thing for 240. So this is one way to get our, that's not right, 240, 240, 240, be 960. 1200. Anyways, we would basically keep going in that pattern until we found what number they both go into. But we have a shortcut here, and that's basically where we're going to try to answer these questions. A second, that's not what I want. So that shortcut is about finding their prime factorization first. So we kind of do this the same as we did GCF, but what we're going to do differently is use the final answer differently. So 108, if we did a prime factorization here, we would do something like this. Okay, so 108 is 2 to the second power times 3 to the third power. And let's do 240, 60 and 4, 2 and 2, this could be 15 and 4, 2 and 2, 5 and 3. Alright, so this one is 2 to the fourth power, 2 times 2 times 2 times 2, times 3 times 5, since there's only one of each of those. So what we now do is we take each of their prime factorizations and we figure out what the greatest power of both of these go for. So let's look at the 2's first. What's the greatest number of 2's? Well, 2 to the fourth is greater than 2 to the second. So we're using 2 to the fourth as part of our answer. What's the greatest number of 3's? Well, 3 to the third or just 3 to the first? Well, 3 to the third. So we're going to times by 3 to the third. Comes up here, and then the greatest number of 5's is just 1, so we times by 5 to the first power, just 5. So that's basically going to help us get our final answer. So we've got 2 to the fourth times 3 to the third times 5. Well, 2 times 2 times 2 times 2 is 16. And times 3 to the third, well, 3 times 3 is 9, times the other 3 is 27. So times 27 times 5. So this turns into a little bit longer sometimes, but this is how we get our answer. So now we have 16 times 27 times 5. So let's do that now. 16, 17, add. So 432. Now we're going to times that by 5. There you go. 2160. And what you realize is if you continued this pattern all the way out and this pattern all the way out, they would both go into 2160. So that is the least common multiple. It's the first number that 108 and 240 both go into. And that's how you find it. Let's go on to example 2. Example 2 has the LCM of 18xy squared and 10y. Alright, so least common multiple, you're thinking expand these numbers. What do they both go into? So you can do that by yourself. I know 18 goes into 90. That would be the first number that it goes into, that 10 also goes into. So I'm just going to say our least common multiple will end up being 90. It will have an x, and it will also have a y squared. But the way we do that is, again, if we're using our shortcut method here, well, not shortcut, but just the method of doing this, we've got to find our factorization. So if you're doing this one, this is 2 times 3 squared times x times y squared, using the letters 2. And then 10y, since it's just 2 and 5, this would be 2 times 5 times y. So now as we look at both of these, remember what we're doing is finding the greatest exponent that's used in each coefficient term. So in both of these, the 2's, well, they're both 2 to the first, so 2 is one of those. In the 3's, this one has 3 to the second, the other one doesn't have any 3's, so the greatest is 3 to the second. The x's, well, the greatest number of x's is 1 of those x's, and it looks like the greatest number of y's is the y squareds. And then, of course, the other thing that we didn't have on there is basically the 5. So I almost missed that for a second. I was looking at it, thought something was wrong. The 5's, the greatest number of 5's that are in either one is 1, 5. So this ends up giving us our least common multiple. We've got to multiply all these together. So here we've got 90 xy squared, which is the final answer. Let's show how we get that. We take 2 times 3 squared is 9 times 5 times x times y squared. 2 times 9 is 18. 18 times 5 is 90 x y squared. So obviously same answer as what we said it would be from the beginning. And you know, it's important to write all these out because I think the more times you do it exactly how I've done it, the more it'll make sense when you haven't done it for a couple months and then all of a sudden on a test this gets thrown in there and you'll remember how to do it because you spent a lot of time on it. So try to do it the way we're teaching, and I think you'll end up seeing a greater difference. Let's keep going to example 3. Here's example 3. Example 3 says find the LCD, least common denominator, of 5/9 and 11/21. So basically, least common multiple, least common denominator. We're trying to figure out what does 9 and 21 both go into. You can write those out. I'm just thinking of 21. If you wrote out 21, it would go into 63, and then I know that 9 actually goes into 63 7 times. So I know my answer will be 63. But to show you with prime factorization, 21 is 7 and 3, 9 is 3 and 3. So this one's 3 times 7, and this one's 3 squared. And just to show you how easy this can be, even with problems like this, the greatest number of 3's is that, the greatest number of 7's is that. So that ends up being how we get our answer, 3 squared times 7, which is the same as 9 times 7, which equals 63. So that's another way of getting it. Either list out your multiples like we're kind of doing here, or do it that way that we just showed, 54, and that's another way to get 63. So this way is one way, and this way is another way. Up to you which way you use, but I do recommend the way I'm showing. Here's another one. Let's go to example 4. Example 4 says replace the circle with less than, greater than, or equal to make 1/6 and 7/15 a true statement. So, again, with fractions, you can get common denominators. This is one way. Times it by 2/2, times this one by 5/5. You end up with 5/30 compared to 14/30, so it makes it obvious that it is a less than sign. Another way you could do this also, though, is cross multiplying. 15 times 1 is 15. 6 times 7 is 42. 42 is bigger. That's another way to show that that fraction is bigger. You can always make fractions into decimals. That is another way to show which fraction is bigger than the other also. So those are a couple ways to determine which is bigger or less. Cross multiply or get common denominators. And then let's take a look at number 5. Here's example 5 showing a table and on this you are to order the flights from least delayed to most delayed, and a negative fraction indicates a flight that arrived earlier. So that would be least delayed is negative. So basically we're doing from least to greatest in that order. Here's all the numbers. We got -3/8. We have 1 and 5/7. We have -1/6. And we have 1 and 1/2. And I hope that some of you do have some shortcuts here to figure this out. But definitely I know the negatives will be first. So which one would be the bigger negative would be technically the smallest, least number. So if we did do common denominators, I would multiply that one by 3/3 and this one by 4/4. That would give me -9/24 and -4/24. So the smallest one would be the bigger negative. So therefore it's -3/8 and then -1/6 in that order so far. So we're done with those. So now what about 1 and 5/7 and 1 and 1/2? Since they both have a 1, then you can just look at the fractions. So we can do 2 times 5 is 10. 7 times 1 is 7. So that means this one is bigger, so that should go last. And 1 and 1/2 is smaller, so that goes in between, since the positives are greater than negatives. And there's your final answer for example 5. Alright, any questions, make sure you ask. Find a partner to work with if that helps as well. Good luck.